Welcome, everyone, and thank you for signing up for my course, Spatial Data Science and Applications, and taking the first class. In this class, we'll discuss what spatial data science is. In order to give you the concept of spatial data science, we'll review related disciplines, science and data science in the first place, and then discuss the definition of spatial data science and its unique aspects. For your better understanding, examples of spatial data science problems will be presented as well. What is science? I present two definitions here, one from Wiki, the other from Webster. The one is focusing on activity or method. The other is more on subject. As a subject, science is a set of human knowledge on general truths. As an activity or a method, science is used to explain events or phenomena about the universe. Traditionally, scientific method pursued finding causal relationship. In other words, it was used to answer why. Why is this happening? For that, a hypothesis was set and tested with experiments, which is precisely designed, particularly removing any biases. Sometimes other approaches could be used, no matter what. Focus on scientific method was always on establishing causal relationship. On the other hand, data science is in the spotlight recently in the era of big data. In the definition of data science, there are three noticeable words: interdisciplinary, insight, and data. Interdisciplinary means that data science requires understanding of multiple disciplines and the combination. Insight replaces the truth in the definition of science, which means that data science is not pursuing general truths or general laws. Data replaced hypothesis and experiment, which means that data analysis is the major tool to find knowledge and insights. The term data science was used by Peter Noll in 1960 as a substitute of computer science. And later in 1997, Jeff Wu mentioned, is statistics equal to data science? All in all, the focus of data science is placed on correlation, based on the data analysis rather than causality. Data science generally does not try to answer why or cause and effect. To become a data scientist, he or she needs to have expertise in a variety of disciplines. DBMS and big data systems, such as Hadoop, should be understood for data handling and management. Statistics, machine learning, and related data mining techniques are essential for data analytics. Experience of data visualization is a big plus for delivery of result and visual analysis. Application domain knowledge is always helpful, but it can be supported by domain expert as a team member. Spatial data science is similar to data science in definition, but there is a major difference that spatial data science equally focuses on both causality and correlation. In other words, spatial data science pursues answers to the question why and also simple pattern of spatial phenomena. Spatial data science is also multidisciplinary, so that spatial data handling and management are important disciplines. And expertise of spatial data analytics and visualizations are also critical qualification of spatial data scientists. Additionally, proficiency of GIS would be very helpful. The difference between data science and spatial data science will be explained in the figure. It can be composed of two disciplines: spatial science and data science. While the one pursues causality, the other does correlation or pattern mining. With a given diagram, the relationship is also illustrated. Spatial data science has overlapped area with data science. At the same time, it has different aspects from data science, which is named as spatial science. We could find quite a few fields related to spatial data science, seeking knowledge of spatial phenomena. Just to name a few, urban traffic problems, healthcare issues, for example, regional prevalence of a specific disease, politics, business intelligence, city operation, hydrology, disaster vulnerability, emergency service, and many others. Let's take a look at the real-world problem of spatial data science. What is the revenue estimation of a new coffee shop of Red Arrow in Evanston, Illinois? Or where is the optimal location of a new coffee shop in Evanston, Illinois? As a similar question of different case, what is the revenue estimation of a new grocery store in Evanston, Illinois? Or where is the optimal location of a new grocery store in Evanston, Illinois? How can you get the answer to the questions? There are two approaches, as mentioned, causality approach and data mining approach. Causality approach based on spatial science investigates supply side and demand side. Location and capacity of nearby competing stores, spatial distribution of potential customers are carefully mapped. And service accessibility models such as gravity model or two-step floating catchment analysis are applied. And then customer shares are estimated and eventually get a revenue estimation at the given location. On the other hand, data mining approach is to find the existing store which has a similar pattern of the new store and then use the revenue of existing store as the estimation. Or build a regression model of which target variable is revenue and input variables are characteristics of the store and its location, and then use the model for revenue estimation. Which one do you think is more appropriate than the other? In general, data mining approach works very well in case of small retail shops, such as coffee shop. On the other hand, causality approach works better for large stores, such as grocery store, department store, and so on. Let's take a look at other examples. The next problem is, how long would it take to leave New York University for Columbia University by taxi cab at 6 p.m. on Monday? Causality approach takes steps such as trip generation to build origin-destination table, models build about decision-making of transportation type, trip assignment to rows, and then get the travel time estimation. Data mining approach uses historical data sets of taxi trajectory. Then find a similar trajectory which covers the origin NYU and the destination Columbia University on the similar condition parameters such as 6 p.m., Monday, weather condition, and occurrence of any spatial event. Based on the trajectory of pattern mining and matching, the travel time can be estimated as well. The next example is a hydrological question. Where would be flooded in the city of New Orleans at the precipitation rate of 1 inch per hour for 5 hours? We can use either conventional hydrological process with spatial data such as digital elevation model, which is causality approach, or a heuristic data mining approach with pattern matching as explained in the slide. The last example is, what is air pollution level at Peking University at 10 a.m. tomorrow? The causality approach is to combine inventory of pollutant emission and weather condition into computational fluid dynamics and estimate air pollution level at a given location and time. Data mining approach would train a machine learning algorithm with historical weather data and pollution data and produce air pollution map with a given condition. We discussed definition of science, data science, and spatial data science. Particularly, the similarity and the difference between data science and spatial data science was discussed in more detail. Yellow portion of the diagram would illustrate similar aspect of data science and spatial data science, while the blue portion would represent unique aspects of spatial data science. In the addition to difference between causality approach and data mining approach, there are quite a few issues which differentiate spatial data science from data science. It requires hands-on experience of different disciplines such as GIS, spatial DBMS, spatial big data system, spatial data analytics. Unique characteristics of spatial data should be also realized and understood to claim the role of a spatial data scientist. In this course, you will learn more about unique aspects of spatial data science. In summary, spatial data science uses both causality approaches and data mining approaches. Spatial data science is not just an extension of data science, and it has rather unique aspects different from data science, which would be a value proposition that you can get from this course. There are four main disciplines of spatial data science: GIS, spatial DBMS, spatial big data systems, and spatial data analytics. These topics will be discussed later. All right, this is the end of the first lecture. Hopefully you enjoyed it, and see you in the next lecture.